Anybody else? You sure? Last chance. I'm going to drink all the rest, and you're going to have to put up with what I'm going to say afterwards. So cheers, everyone, to my European debut. Across the hall from dropping the iPhone O-Day. And there will be no O-Days in this talk except one. There is one O-Day that I came up with last night. So I was walking around Amsterdam with some other speakers, and we saw this weird device on the side of a building that kept like moving around, and we couldn't figure out what it was. So of course we Googled it to find out what it was, and it actually like runs the subway. It talks to these little mirrors on the ground to tell whether the subway is like sunk or not, because this used to be a lake or something. Like all of the Netherlands used to be water and they reclaimed it. So theoretically at any time the subway could just like sink into the sand and it would all be over. So there's this device that checks to see if it's sunk a little bit. So my O-Day, how you can shut down the subway is, take a little chisel and drag up the mirror and like move it up like an inch, and it'll make the subway completely freak out, I think, and it'll stop. So you can stop public transportation in Amsterdam with this O-Day that I just dropped. And that's my only O-Day. The rest of it, we're just going to talk about boring old Android stuff. So, really, nobody wants any more? Come on, look how full this bottle is. We are in Amsterdam, ladies and gentlemen. All right, well, I'm Georgia. We're going to talk about Android, and I have a little company called Bulb Security that does some security things. If you need security things done, come get a business card after the talk, and we will do some security things for you. So, first off, the first thing I have to do when I do any research is completely discredit everything I do and say it's completely not worth it. Because we're going to talk about bypassing the Android permission model, and I'm going to show you that you don't have to bypass it at all, that the permission model is just so completely flawed there's not even any point in bypassing it. So I'm going to show you an app. I'm not going to tell you what it is, but I'm going to read its permissions, and then you get to guess what it is. And its permissions are kind of scary, so I'm just going to read it right off my phone, actually. All right, so the permissions that this app asks for at install are the following. It wants access to your personal information. It wants to read my contact data, so it can see everyone I have stored in there, including my work contacts. This doesn't just include the phone book. It'll include all of your email settings as well. So if you have this synced with your work contacts, it can see all of them, see their email addresses, phone numbers, names, company affiliation, any data that's actually stored on the phone. It can also write this information. So for instance, your boss, it could overwrite with its own email address. So then all your emails to your boss with, for instance, your reports in them, the new version of your pen test report for company ABC is now going to someone else. That's not a problem. No. It also wants this thing called services that cost you money. Generally, that tips me off that it might be a little bit scary if it's going to cost me money. It wants to be able to send SMS messages under that heading. So it wants to be able to send text messages. It can still send them if I'm in Amsterdam, and it's going to cost me 10 cents a text message. I got a very nice text message from my phone provider that said you've already spent $50, and I had only been here for a couple hours, so yeah, I should stop playing with my data so much when I'm roaming. But it can send text messages on my behalf. It can also send them when I'm in Amsterdam. It can send them to 900 numbers that cost more money. It can send them wherever it wants, and they won't show up in my sent folder, so I have no idea that they were sent at all. It also wants access to my GPS location. So when I got lost the other day and I turned on my GPS, any app on my phone that asked for this could now see that I am in fact in Amsterdam and not at home. So good time to rob my house, right? I'm not there, and my phone knows it. It wants access to my messages. It wants to edit SMS, so read my text messages, change them. It also wants to be able to receive them, and oddly enough with Android, if you have the permission to receive SMS, you can receive them before the actual text message app does. So you can keep users from ever seeing their text messages at all. which is a good way to run a botnet, I think. If you're at all familiar with my work, that's my big thing is the SMS botnet. So it's a good way to run a botnet, just to intercept people's text messages. And they gave you explicit permission to do so, so you're not even doing anything wrong. It also wants access to my accounts. It can act as an account authenticator, so it can log into any other account I have on here. So since it's an Android, it has my Gmail, of course, but anything else I have on here, like for instance, Twitter. I love me some Twitter, so it can log on to Twitter for me. It can also manage those accounts, so theoretically it could actually lock me out of my account. It could change my password and make it so that only the phone can get on my Twitter ever again, and that would make me really sad. I don't know about you, but I think I would just die if I lost access to my Twitter. It wants to be able to modify and delete USB storage contents, so it can read anything from the SD card and it can delete it for me. That might be a good thing. I don't know if you guys over here, so much as we in America like to take pictures of ourselves being drunk and stupid on our phones and then post them online. Theoretically, if an app, there actually is a startup in California right now that the whole idea of the app is they're going to delete your pictures for you like after an hour. So there aren't all these incriminating pictures on your phone, so that might actually be a good thing. That one permission right there that will delete incriminating pictures of you doing stupid things in Amsterdam, like drinking on stage. Hey! Let's see, it wants to make phone calls. It wants to read the phone state and identity. The phone state and identity, that's one that users are like, what does that even mean? But that actually is the personal identification number. It wants to read your IMEI, so it's a unique number to your phone. And a lot of developers use that as a way to uniquely identify you with the server, which you could think of as uniquely identifying you based on your credit card number. That sounds like such a great idea, doesn't it? We don't want that going back and forth to a server, but yet that's the cool thing to do with Android. So a lot of apps ask for that, and theoretically none of them should. It wants to prevent my phone from sleeping. If any of you have Androids, you would see why keeping the phone from sleeping might be a bad thing. It runs down your battery, and battery is God in Android. And it wants to write my sync settings. So next time I plug it into the computer, I might have a little surprise coming. And then the final one, it wants network communication. It wants to be able to talk to the internet. Anybody want to guess what app this is? Facebook. Yes. May I introduce you to the absolutely most popular Android download of all time, Facebook for Android. Yeah. That's a lot of permissions. See, I've had Facebook forever. I was in college when Facebook first came out, and you had to have a college like .edu email address. I love some Facebook, but my Facebook on my computer, it has one of those permissions, ability to talk to the internet, none of the other ones. And it works great, and people love it, and they just made billions of dollars. So why do they have all these? I don't know. Actually, I do know. I figured out why. Since I've done so much Android development lately, and I've watched my apps just fall over and die randomly, and I can't figure out why, and nothing comes up in the debugging settings, why it's falling over, go to Stack Overflow, they give me the source code that looks just like mine, so it must work, right? It's Stack Overflow, no problems there. And it just falls over. I figured it out. It's because I didn't have the permission. It just dies. Because if you don't have the permission, you can't use the functionality. So developers are just asking for all the permissions so they don't forget later. And then they forget to take them out because Facebook doesn't actually use half of these. I've read the source code. I would know. So naturally, having seen this, I thought, how hard would it be for me as not necessarily a very good developer, certainly haven't had much experience in Android yet, how hard would it be for me given that users are willing to accept these permissions? They accept them on Facebook, they accept them on any other app. If I put out an application that asks for a lot of permissions, I can assume that users will accept them. How hard is it for me to code ways to abuse this? So naturally, I wrote an app to see. So we're going to look at a little demo. All right, so I've got my Android and I've got my iPhone here, and somehow I've lost my laser pointer. So I wrote an app called Hello Android, not a very sophisticated name. I'm just going to install it off the SD card and replace what's already on there. What? Stop. Okay, so it wants 3 permissions, a lot less than Facebook. It wanted the ability to read your contacts, read that IMEI, and it wants to be able to send SMS. So it puts up a screen that says, hi, basically I just exploited the hell out of you, but of course a bad developer wouldn't have to put up the screen at all. They would just put up a game or something, and this would happen in the background. I go to my sent folder and I see that I have sent no SMSs. I have no indication that anything has happened here. But if I go to my iPhone, I see that I have sent the IMEI number, my personal identification number, worth about as much to an attacker as a credit card, so about 10 cents. So basically nothing, but if you have millions of them, you see how this adds up. How malware writers actually make money is a mystery to me. They make a lot more money than I do. It's probably best that I don't find out, so I don't turn to the dark side. But anyhow, so we just exploited all of those permissions. The ability to send SMS, we did it in the background where the user couldn't see it. It wasn't in the sent folder. No indication it happened. The only indication was that screen I put up that says I did it, which of course the user will not see that with a real evil application. This will just go on in the background. So it stole your IMEI, sent it to someone else, and it also put up the last person you talked to based on your contacts, so it could tell who the last person you talked to was. It could also read all of them and send them off. If I had asked for network communication, I could send this up to a server. So the moral of the story is it's really, really easy to write Android malware without exploiting it at all. Just given the amount of permissions that users are willing to accept, you're able to completely exploit them in any way you want. So I've basically just undermined the whole rest of the presentation. This research never needed to be done because you can just ask for the permissions and exploit them that way. So there's no reason you have to steal permissions. There's no reasons you have to root their phone. You can just do this. But now we're going to talk about it anyways. Marco, you missed the giving away of alcohol. Would you like some tequila? We've been to Colombia. This is good alcohol comparatively to what they feed you there. Yeah, Aquadiente. Yeah, okay, if there's any left, you never know. All right, so basically what happened here as a rundown, I asked for 3 permissions. Read the IMEI, which comes up a lot. A lot of apps ask for this. They should not. No app should ever ask for this, because the only reason to ask for it is to uniquely identify you on their server based on your IMEI, which is like uniquely identifying you based on your credit card number. We don't stand for that in secure coding. That's bad. But we allow it in Android. Read your contacts and send SMS. And we exploited every single one of these. We stole your IMEI, we saw the last person you talked to, and we SMSed the IMEI to ourselves, all in the background. Which brings us to the next topic. A lot of the malware in the world roots your Android. A lot of the not malware in the world roots your Android too. We want it to root it. We want complete control over our phones. We buy the device, we get control over it. Not so much necessary with Android as it is with iPhone. Basically, if you want to do anything with your iPhone, you have to root it, but you'd probably be over there in the other room if you were interested in that, because they're showing Absinthe right now at the same time as my talk. So thank you all for coming. So these are 2 of the prevalent rooting programs. Super One-Click still goes on. They update regularly. It does like the most recent versions of Android. But back in the day, and still for a lot of phones, because you're not getting updates, because Google doesn't update you or your carriers do not, Z4Mod was the rooting solution for up to like Android 2.2, which sadly still works for a lot of Android users. I've looked at the source code of both of these. I'm going to talk about evil exploitation for rooting, and neither one of these exploit you evilly. They give you your super user permissions and then they're done and they go away. So do not come out of this thinking that these two apps are evil. They are not, and I use them regularly. But we are going to look at some evil ideas for rooting Android. Anybody remember this guy? Droid Dream made a huge media splash because researchers like me and you had been saying for a long time, anybody can put anything they want in the official Google Marketplace. So it's really only a matter of time before something evil shows up there. And of course, everyone's like, no, that'll never happen. You'll never get malware into the Google Marketplace. And then Droid Dream showed up, the first known outbreak in the Google Marketplace. And it rooted your phone, stole your information, and did all sorts of crazy evil. And it was just sitting right there in the Google Marketplace waiting for you to download. Whereas every previous outbreak had been in some third-party market that had a lot of Chinese characters in it, and really if you downloaded it, you kind of deserved it, right? I mean, you couldn't even read what it said. But this looked normal. This was inside of the official store that all end users were basically paying to use by buying an Android device. So they had some reason to believe that this would be a safe place for them to find applications. But because there's absolutely no oversight of all these applications, there's millions of them, this would take time, this would take effort, and iPhone users always complain that it takes so long to get updates into the store or get your apps in the first place into the store. The idea that things go into Google Store automatically was awesome and people loved it, but then stuff like this started to happen. But now, of course, if you get Droid Dream now, since it's old, Lookout or any other antivirus program will flag it and say, this is Droid Dream, you do not want to install this. But of course, at the time when this first came to light, this was not the case. It just looked like a normal application. What should have tipped some people off is how few permissions Droid Dream actually asks for comparatively to normal applications. We just looked at a normal, non-malicious application, Facebook, that wanted this long, long list of permissions. Droid Dream actually only asked for 4, which might have tipped some people off that something was up here, because you never find an app that only asks for 4 permissions. Never. They always have like 10 or 12 scary-looking things. So it wanted access to the internet, normal one there. Apps want access to the internet, that doesn't scare me. It wanted to read the phone state, so it wanted the IMEI. I've said that's bad, but it's prevalent. A lot of apps ask for it, so it wouldn't tip anybody off that anything was wrong here. Basically, it's probably checking in to the server using the IMEI to uniquely identify you. A lot of the Droid Dream variants were games, so this would be how you check in your scores. This is normal for Android. Definitely not a good idea, but it happens. And then the other two, it wanted to be able to change the Wi-Fi state and access the Wi-Fi state. So theoretically, it just wanted to be able to make sure you were on the Wi-Fi before it sent things. So, wow, this app's really looking out for me. It doesn't want to run up data charges for me. It's only going to check in when it's on the Wi-Fi. No, that's actually not what it was doing at all. One of the routes it uses actually requires you to change the Wi-Fi state, like basically toggle it on and off before the shell hits. So that was actually malicious. But looking at those, that doesn't look that scary comparatively to most apps. Just looking at that list of permissions as an Android researcher would think that's a really small amount of permission coverage. That's not really that scary at all compared to most apps. But this was actually one of the scariest apps of all. So how did this actually work? Basically, when you downloaded Droid Dream, you saw something like this. There were many variants of it. Some of them were, for instance, like adult dating sites or adult videos, which some people say I should use that as the demo, but we're actually looking at one called Bowling Time, which is just you play bowling on your phone and try and knock down all the pins. Pretty boring, comparatively to the adult sites, of course. Tequila. But then in the background, behind all of this, was where all the evil happened. Basically, when Droid Dream would start, it had copied a bunch of normal apps like this that even had nice ads. You see there's ads up there, Apps with ads, those are never scary because they're paying their dues to advertisers. but it would start the regular app in the foreground, so it would call it to start, just basically steal the straight up source code from the original app, send it off to make it appear on your phone, and then do evil things in the background. So users would be none the wiser that this was any different than the original app. And then it would root you in the background. You hadn't downloaded anything and told it to root you. It just did upon install. When it started, it automatically tried 2 root exploits, which at the time were unpatched on all the phones. By the time Droid Dream hit the news area, these had been updated on official Google phones, but most phones had not had it pushed out to them yet, so this was basically an O-Day for the entire time of Droid Dream. So basically, if you installed the Droid Dream app, you were going to get hit by one of these, because it not only tried 1, but it tried 2, and these were the same ones that the rooting applications were also trying. Oddly enough, I looked at the source code of Droid Dream, I looked at the source code of Z4Mod, and I'm pretty sure Droid Dream basically just copied the source code, because it's even got the same variable names. So the source code was out there, the Droid Dream writers copied it, put it in their app, and went on their merry way with it. So that's how it happens, I guess. So what Droid Dream did after it rooted you, if one of those 2 roots actually worked, and again, they were basically O-Days for most phones, even up until the end, because people hadn't been updated. They had not had patches pushed to them by the time it hit the media, unless you were, at that point, a Nexus 1, because that was the only one out then. So unless you were Nexus 1, you were in trouble through the entirety of the Droid Dream time on the marketplace. So it rooted your phone, it gained super user permissions, it could write to the entire disk, including the system partition, which is where apps that are installed at like the base install by your carriers are, and theoretically no one else should be able to write there, but of course if you're root you can write wherever you want. And it installed packages as system, and at that point the permission model completely broke down. There are permissions that you can ask for as system that you would not even dream of as a developer. You can do anything you want there. You have complete control of the phone. And now Droid Dream has that as well. So it has access to everything it wants. It stole your personal information, it ran up your phone bill, sent it out to its CNC server, so it suddenly had access to every permission available. That's rooting your phone. Permission model gone. Which brings us back to these guys. Again, I've read the source code of both of these. Non-evil, they give you your super user and then they go away. But say, for instance, you're looking for Z4Mod and you spell it with 2 O's and you end up at a website that has something that looks a lot like this. I mean, it can get the source code so it can pretend to be this, but it isn't. It does root your phone. You come out of it with super user permission, so you as a user are happy. You got what you wanted. But what happened in the background? You have no idea, because it's all going to go on behind the scenes. So I'm going to show a demo of something you might want to do after you root somebody's phone if you were a malicious attacker. This is one of my old stories of evil things you can do to phones. So I have 3 phones and you can hear me talking. Whoa, what just happened? My screen just went all up in there. Okay, let's go back. Go back. Macs are so complicated. Don't use Macs. Yeah, tequila happened. Let's do some more tequila. All right. So you can tell this is an older demo because of the older phones. We have 3 G1s here. So the one that's still lit up is the attacker. The one in the middle is the victim who has been maliciously rooted. And the one on the far left for you guys is just a friend of that person who's in their contacts list. So what I, as the evil person, want to do is I'm going to send an SMS message to the phone in the middle, to the one that has been maliciously rooted. It says bot, and then it says spam, it has a number, and then it has a message. That doesn't really mean much to anyone, but it means something to the program on the other end that is now going to be able to intercept your messages and act on them. So this is actually just code to talk to the phone in the middle. So I sent a text message to the phone in the middle. We know how text messages work. It shows up on the middle phone. They see this nonsense about bots and they go on with their life. But what we actually saw happen is the phone on the far left is the one that actually got the message. And the message it got does not say bot spam and blah blah. It just says hello, hello. And it says it came from someone named SlaveBot, which obviously is a fake name. No one would have anyone in their phone as SlaveBot. But that's actually the middle phone. To prove that I'm not all making this up, I just send the message hello, a normal message, to the middle phone again. And this time it shows up normally on the middle phone. So basically what you've done here is the phone in the middle has sent a text message that they don't know about to the phone on the far left. They also received a message they don't know about, this bot spam message. And because we rooted their phone and gained access to system level, we were able to do that without requiring any permissions whatsoever. So now we've basically made them a member of a botnet. What would be interesting is we grab all their contacts, send them a message that does not say hello, hello. It says something like, look at these cool pictures from last night with a link in it. The link pops their browser, exploits it with a known exploit, and then makes them part of the botnet as well. So that's why rooting can sometimes be evil. So how this actually worked in this case is once I gained root access, I had access to the entire file system, not just the application layer. This is basically what it looks like when you're talking to the modem from the application layer. You have user space on top, which is where your apps are, some like at the base, like kernel level modem drivers, and then the modem itself, the hardware. So when you receive a message, it comes up here through the modem, through the drivers, finally hits the application. When you send one, likewise, starts at application layer, goes through the drivers, finally hits the modem. So after I rooted their phone, I basically installed the bot level shim there at the kernel level, because I have access to that now. When you get root access on somebody's phone, you have access to everything, so including kernel level. So I would basically just intercept messages coming in and out, and this would be platform dependent. You'd actually have to be able to talk to the specific hardware, which at the time, as you saw, these were G1s. Those were the only Android phones at the time. Now that there's a zillion of them, this is a lot harder to do. Doing stuff at the application layer is probably better for malware writers. But if you can write this for the specific platform, this sort of thing will never be detected by antivirus because it's too low level. It's in the kernel. And everybody who ever roots your phone, every piece of software you ever go to and say, please give me root privileges, could do something like this. So basically, the other caveat is that SMS and all of basically your traffic over the GSM or CDMA modem is completely unencrypted, except it's encrypted with a session key in transit based on whether you're 2G, 3G, 4G. But by the time it hits your phone, it's not encrypted anymore. Nobody who's malware on your phone has to gain access to your private keys or anything. It's all just going to be encoded. This is what your text messages look like. You can break it down into what it actually says. You have the sender number, which is just the 2 digits flipped. Like if you can very quickly flip those 2 digits back out, you can get my phone number and you can call me. Obviously, I don't have an F at the end. And then the message here is just 7-bit GSM encoded, which there's tutorials about how to do this on the internet, and there's code to get it back out. I wrote one. There's one on my website. If you actually teach beginning programming, this would be a really cool exercise to like get SMS messages. You know, everybody gets the packets and they break down what the packets say, but doing like GSM packets, I think would get more computer science students, because kids today are obsessed with their phones, really admit it, it's true. So this would be a cool exercise. But you can tell what everything in this is with no keys whatsoever. You don't have to do any encryption. So if you're on the phone somewhere, you've got access to everything without encryption at all. So basically how this would work is it would receive all the messages, everything that comes into the phone through the modem it'll see, because it's below application layer, so it'll intercept it first. If it's an SMS message, it'll decode the user data. If it's not an SMS message, it just sends it straight up to application layer. We want users to still get their same information. So if it is an SMS, it'll decode it. It'll check and see if it has the bot key. In my case, that was just bot with a colon, not a very good key, because then anyone can piggyback on your botnet, and that's the last thing you want as a malware writer, is to have other people steal all your hard work and use it to do their bidding instead of yours. Nobody wants that. But if it does indeed have the bot key, it'll perform functionality for you. For instance, I told it to spam, which it knew based on its programming meant send an SMS message to someone else with this data. So just straight up C code. I mean, down there at the bottom of the Android, it's just, you don't have to know anything about content providers or intents. It's just straight up C kernel. So if you, as a malware writer, have written anything for Linux, you can write for this quite easily. So easy transition to working on cell phones. So mitigations for these root level attacks. Users need to update their phones. We always tell users they need to update. I never thought I'd say anything nice about Microsoft. First Tuesday of every month, I know that my Windows-based machines are going to update, and they get the latest patches, and it's good, and it's restarted in the morning, and I've lost all my data that I forgot to save, but at least I have my updates. Not so much with my Android phone. I used to complain that Android was the best for updating, because it used to be you had to plug in your iPhone to the computer in order to get your updates. Same way with the BlackBerry. Now both of those push over the air as well, so they've caught up with Android there. But all the iPhones get the updates pretty much at the same time. You get your updates. You get your updates for BlackBerry. You don't get your updates for Android. Google phones get their updates. So if you have a Nexus 1, Nexus S, or Galaxy Nexus, when Google puts those out, you'll get them pretty fast. They'll come over the air to you. Will you install this update and lose your root? And you'll say no, because you don't want to lose your root until somebody's rooted the newest one. Admit it, it's true. No, nobody wants to admit it? Okay. You guys should drink more. Then you'd admit it. However, everyone else who is not a Google platform, it takes a while for you to get your updates. You might have noticed this. You see, it happened with Droid Dream. It happens every time there's an attack. We don't have our updates yet. Why do we not have our updates? Well, they have to take the Google firmware and they have to port it to their specific platform, make sure all their default install apps still work, and finally push it out to you. This can take 6 months. This can take a year. In some cases, this may never happen. Like my mom's friends get this idea like, oh, your daughter's an Android hacker. Can she root my phone for like $50? And it's like, I just started a company. Why not? Apparently, there's these websites that charge like hundreds and hundreds of dollars to root your phone. Seriously, these people are making bank on this. But, you know, I get somebody's phone. I'm like, oh, it's going to be the most up-to-date version. This is going to be hard. And I get it, and it's like Android 2.1. 5 minutes later, okay, done. People never get their updates at all. Like the G1 never went past 1.6. Any exploit after that, anybody who has a G1, vulnerable. Older platforms, you get people who never got past 2.0, 2.1. Nobody updates to the latest version. And they're vulnerable to everything after that. And that sucks. Because we can't really fix that. If the updates are not available to them, we cannot shake our fingers at them and say, you must update your phones. You are vulnerable because you didn't update. If the updates are not even available to these people, if they have to buy another $500 phone and pay a 2-year contract, I'm not sure how it is here in the EU, but in America, you buy a 2-year contract and then you get the phone, and so you have to be with the carrier for 2 years or else pay a fine, and you still have to pay a lot of money. So buying a new phone is a really big deal in America. And, you know, you can't really blame people for staying with the old one, but they can't update it. So this needs to be fixed. So far, we've talked about evil Android guy with horns, evil application that wants to hurt you, and is malicious. And when you download it, it's going to exploit you in some way. But now we're going to switch gears and talk about this guy. Normal Android. Not scary at all. Android is awesome. I pick on Android a lot in this talk, but Android is my favorite platform by far. I often say I want to throw the iPhone across the room, and as a developer, I do. It's hard to develop for the iPhone. It's easy to develop for Android. They make it very simple for programmers to do lots of cool functionality. So a lot of people are developing for Android, and with that comes the caveat, because Android's got some new things in it that if you're a secure developer, you've thought a lot about how to stop buffer overflows, SQL injections, things you're used to. Now you've got content providers and activities and services and intents. You're not used to these. These are new. These are things that might have some security caveats we're just not used to as secure developers, as a security community that are just open and we're not sure how to deal with it yet, which is a lot of what you run into. It's people who just don't know because it's new stuff. So first off, the simple stuff, the stuff we should be thinking about. Android storage. Android apps are cool because every application has its own user ID. This is a Linux model, and it's read-only by default. The only person who can see your data is you, because you're the only one with that unique user ID. Other applications on the phone cannot see it. The problem comes in when you want to share it, of course. A good place to store things is the SD card. We store all our pictures and our musics and things there, and then when people switch phones, they can still have that with them. There's a problem with the SD card, though. It's VFAT. If anyone's familiar with VFAT, it's read-only. No, it's not read-only. Not anymore. It's world-readable. So anyone can see anything you put there, any app. And if you still store it on the internal storage and you want to share it with someone else, naturally the idea goes to, let's just make it world readable. No one will know the file name. Who cares? Not so much. So naturally, seeing this stuff, I thought, how hard would it actually be to steal data from another application? So I wrote one. Bad storage. All right, so we've got more up-to-date Android platform and iPhone. And we're going to look at two applications. We're going to look at one that stores data in an insecure manner, and we're going to look at another application that steals that data. So you may not be aware of this, but after you install applications, you can still see all the permissions they ask for if you go to settings. You think that you just see it upon install and you say yes and that's that and you're stuck with it, but you can actually see it all. So I'm going to look at an app called Bad File Save, which no one would ever install, of course, but they want to modify and delete USB storage content so they can write to the SD card, and they want to read the phone state and identity, so they want that IMEI number. So you might be able to see where this is going. They want to read it, and they want to write it somewhere that's world readable all the time. That sounds like a recipe for disaster. So then I have another application, Bad Send File, that it does not ask for access to the IMEI number, so it should in no way ever be able to access it, and certainly not be able to send it to another phone, but it asks for the ability to send SMS messages. So again, you might see where this is going. This should not be able to access the IMEI, but it does have the ability to send SMS. So I wonder what's going to happen when I call it. Let's see what happens. So I call Bad Send File. It says, hello Android, I am an evil app. It could have any app it wants here, or no GUI at all. It could be just a service in the background. And I see that my IMEI has been sent to the iPhone. So data it should not have had access to, it was able to access. So rather straightforward example here. So basically our green guy is our good application. It stored its sensitive data on the SD card. This need not be the IMEI, this could be usernames and passwords, encryption keys, anything else that we might want to keep others from seeing, not just on the SD card, storing it world readable inside of the actual Android storage would work the same way. As long as you have the file name, you can then access it. SD card is world readable, so since we stored it there, we're able to see it. In comes our bad guy with the evil horns. I can only get one laugh out of you for the horns, okay. So it discovers how the data is stored, finds out that it's stored on the SD card. Anybody can read the SD card. We don't have to ask for permission. We saw in the demo that it only asked for SMS. It didn't ask for permission that said read to SD card, whereas the other one asked for write to SD card. Anyone can by default read from the SD card. So anyone can see your pictures from last night, any app on your phone. Just saying, maybe you want that app that deletes them, who knows. And then it sends it to the attacker via SMS, which it asks for that permission, so it has that ability to do so, not doing anything evil there. It has the ability to read anything from the SD card. It has the ability to send SMS. So technically, this didn't actually exploit you. Code examples. Everybody hates it when you show code examples in your talk, but these are really short ones, just to illustrate how easy this is. So this is everything in bad file save. It basically just reads the IMEI, which only takes a couple lines, and you can look up on Stack Overflow how to do it. Something interesting about Android is if you want to exploit the Android, really just Google online, how do you send someone's IMEI to yourself via text message? And there's code examples that'll show you exactly how to do that. You don't even need to, because it's not exploitation. You ask for the permissions. This isn't evil. It's hilarious, really, the stuff you can find on the internet that'll, even if you don't even know how to code in Java, will show you how to do this. And then it stores it to the SD card in a file called IMEI, string file name. That's not a very good file name because that pretty much says exactly what's in there. And then bad send file, knowing that it's called IMEI, reads from the SD card, which is a default permission because it's not considered scary, and then reads what's in that file and sends it via SMS. Since it has that permission, it can do so. So it just sends an SMS. And as a former baseband programmer who wrote kernel code to send SMSs, being able to do it in 3 lines right here is really awesome. So that's that. But wait, we relied on one little caveat here. We knew what the file name was. How did we know that? How did we know what they were storing there and what it was called? It's actually quite simple, using open source tools to basically get the source code out of an Android app. There's talks on like reversing Android apps that do a lot better job than this, but just for the basics to get the source code out and review it, you can do it just with these 3 tools here. You unzip the APK and you use a free tool that's on Google Code called dex2jar that will reverse it back to source code from the compiled Java code. And then open it up in a tool called JDGUI, which will show you the source code. These slides are online at my SlideShare, slideshare.net/Weidman, and there's a link to the white paper that describes all this. It takes a malware sample and shows all this and reversing the malware and looking at what it's doing. So if you're interested in malware reversing, this would be a good place to start with this paper. For instance, this is Facebook. I said that I had read the source code to Facebook. This is how. Very big app there. It does a lot of things. And then this is Droid Dream. You don't see this very well, but there's some nonsense here. So the caveat is this isn't 100% perfect. Sometimes it gets it wrong, but there are more sophisticated ways of reversing Android. But just to get the basics, you can do this in like a minute and a half and get basically the entire source code. Like, if you can see it, it says Rage Against the Cage up there, which generally gives me an idea of exactly what this is doing. And then it wants to go to system bin sh and run that. So, I mean, just from, even though this is not 100% correct, just looking at this like a minute and a half after I download it, I can generally get the idea. It wants to use the Rage in the Cage exploit and then run it. And then we get something wrong. It says while true, if I is less than 0, while true again, and then return, and then do some other stuff. But of course, after we've returned, we won't ever do any other stuff. So I sit there and think, what is this? This is really weird code. I've never seen anything like this before. And then my mom walks by and she's like, wow, your decompiler sucks. And that solves my problem of what this means. My decompiler was not completely 100% correct, but it did give me the gist of it. And I've never come into a time where it wouldn't give me like file names and such. So this will definitely get you what you need for this sort of attack. So mitigation for storing things incorrectly, just store things correctly. You have a really good model here is that you can store things securely because you only have your user ID and no one else can see it but you. So don't store things on the SD card. That's VFAT. We don't like that. Don't store them in the source code because as we saw, we might get those strings back again. And don't store them world readable. You can store them, if you want to share them with others, you can share a user ID, or you can store them in a SQLite database and share it, but don't share them these ways. This is bad. So then the last and most interesting, I think, Android interfaces. If anyone's ever done any Android programming, one of the reasons Android is so awesome, for instance, if you want to talk to the camera and take a picture, you don't have to do all that underlying programming to talk to the camera. You don't have to talk to the camera at all. All you have to do is call the open interface for the camera app and tell it, please take a picture for me and please return it to me. And it nicely does and gives it back to your application and you can go on with your life. So you don't have to do any camera programming whatsoever. Twitter app, that's an example of that. You take a picture and then it says, do you want to send it to Facebook? Do you want to send it to Twitter? And then it just sends it off nicely for you. So as a developer, that's awesome. As a security professional, that sucks. Because all of these open interfaces may allow you to actually steal permissions. So naturally, I wrote an app to do this. Bad interface. So we have our two phones again, our Android and our iPhone, and I believe at the beginning of this I expostulate about what's going on, but no, I've already picked up the phone. So I go to settings again, and I'm going to look at the permissions on these apps. So I go to apps. I have an app called SMS Broadcaster, which if you're familiar with Android means broadcast receiver, which listens for intents, which are messages between applications. It says it wants services that cost you money. It wants to send SMSs. That's its only permission. Then I have an app called SMS Intent, which has absolutely no permissions whatsoever. It should not be able to send SMSs or do really anything else. So I call SMS Intent. And what I see up here is it called SMS Broadcast Receiver, which naturally is an activity instead of a broadcast receiver. If you're familiar with this, a broadcast receiver has no UI, but I made it an activity so you could see what actually happened. It called the other application and made it perform functionality. It put up a UI. It need not. In a malicious scenario, it would not. There would be no UI, no indication that this actually happened. But what happened is it called the other application. Come over to my iPhone, I see that it sent me a text message. So the app that I actually clicked on was SMS Intent, no permissions. I never clicked on SMS Broadcast Receiver, I never called it, so I just sent an SMS without the permission to do so by using another application. And I see I'm about to turn red over here, so I'd better continue. So basically, our good application, when it's called, it sends an SMS. So why this would happen is, for instance, if it's a game and it wants to check in your scores, this would be one activity or broadcast receiver or service. So one component of an application that sends an SMS, for instance, with your scores in it. So it would naturally assume that only its own application would ever call this. I don't export it, so the only way to call it would be to know its name, know its package name, and know its actual interface name, so SMS Broadcaster. It would have to know that. And there's no way we could know that, right? Because we can't get the source code of the app, so there's no way we could know the name of it. Not at all, right? No. So basically the caller tells it to send an SMS, And we assume that it's only going to come from the same app, so this is normal, nothing bad here. It's going to send your scores off when it gets the correct intent or message from another component telling it to send it. In comes our evil app with the horns, and it calls broadcast receiver and tells it the number to send the message to and the message to send, and thus has the ability to send an SMS message without the actual permission. Code examples real quick. So SMS broadcast receiver, basically when it's called, it has default values, but it gets the intent, which is the message, and you can store additional data on the message. So it looks for two specific keys, message and number, pretty easy here. The message you want to send, the number you want to send it to. It looks for those. If the intent it gets doesn't have those, if it gets a weird intent, it just sends a default. So it won't crash, but it looks for those if they're there naturally, because we can reverse this, we can see this code, we know we need to send an intent with two keys, message and number, and the data we want it to actually send, and where we want it to send it in message and number. So we can then formulate the intent, we know where to send it to. The package is higher up here in the screenshot that didn't make it, but we need the package, we need the name, so the class name and the package it's in, and then how to make the intent, and then we've got everything we need to make this do our bidding. So in SMS intent, we do just that. We create an intent, so a message to send to another component on the Android. We tell it the package. We tell it the name of the actual activity or broadcast receiver or service or any interface we want. As long as we can call it by name, it doesn't matter if it's exported to us. We can actually just call it. We give it the strings we want it to send. We want it to send a message that says test test, which could be anything, and the number we want to send it to. We put those extras into the intent, giving them the keys that we found in the previous source code, number and message, and then we send the intent off, and it will call the other one. So it'll call SMS broadcast receiver, which when it's called just sends a text message. No user interaction required. It just does it if it gets the correct intent, which due to the source code, we were able to see how to do that. So mitigations for this, basically don't have your dangerous functionality. Anything you have to ask for a permission for is considered dangerous functionality on Android, so don't have it just directly available. For instance, an easy way to deal with this is to just have users have to click OK before it sends off their scores. Have it like put up a toast or a little message box that says, can I send your scores to the server? And you have to click OK or cancel. And so then when SMS intent called SMS broadcast receiver, it would put up that message and users would be like, I didn't just play the game. They'd probably click OK anyway. Admit it, they probably would. But at least it would give them some hope. Another thing you can do is there's actually a little known tag in Android called require permission, which you can put in your XML. And for when you have to declare all your interfaces, so all your activities and services and such, you have to declare them in your manifest. And when you do that, you can just use the require permission. So we could here say require permission, send SMS. And then when any other application or any other interface, even inside of that same app, has asked for calling this interface, it'll check and make sure they have that permission to send SMS. And when they don't, with the case with SMS intent, who had no permissions, they don't have the ability to send it, it'll just say no and it won't work. But hardly anybody uses that. And the reason for that, I think, is mainly because, one, obviously developers don't think about secure development, they just want cool fireworks and stuff to make people download their apps. And also the problem is Google itself. If you've ever looked up how to do Android programming, you'll see it shows you lots of nice demonstrations and tutorials. It starts out with Hello World, just like everybody else does. And you do Hello World, and then you make something called the Notepad application. But in none of those tutorials does it ever actually ask you to look at the security page, which is all out there, and a nice security page that talks about all of this that we've talked about. But new developers, they don't ever see that. So this is how you contact me, and now I will take questions. Any questions from the audience? Anybody want more tequila? This thing is not empty. You know you want some. No? Really? No questions? No nothing?